Before your, can you share your screen?
Yeah, let me share my screen. Okay, let's 1 second. Mm, Share application entire screen. Yeah, I hope you are able to see my screen. Okay.
Yes, yes. Put it in full screen mode if possible.
Yeah.
Yes. Dear participants, among with us, Mr. Suren Chalika. He is a principal engineer at Siemens India with over 15 years of extensive experience in model-based system engineering and multidisciplinary engineering. He holds a master degree in aeronautical engineering from the prestigious Indian Institute of Technology IIT Kharagpur. Since joining Siemens in 2010, Mr. Suren has played a pivotal role in supporting and leading a various system engineering projects across the aerospace, defense, automotive, and marine sector throughout the Asia Pacific region. His deep expertise and commitment continue to drive innovation and excellence in complex engineering environment. Now I am requesting Mr. Suren Chilika sir to address the audience or participant with your deep thoughts.
Thanks, Saroj. Okay, nice introduction. And I would like to, okay, brief about myself. And you know that, okay, as Saroj mentioned, I am very closely working with the various the system engineering projects across the India, where actually for I involved most of our indigenous programs of India. Okay, either from this marine sector or from this automotive side, and as well as from this aerospace and space sectors. So this is about me actually for the today's session. What I'm going to be talk about that what is that the current trends, the industry 4.0. Okay, and what is that critical elements as a university you can pick from here and you could support for this particular the industry. Okay, that's what about my the today the discussion. Okay. So I'm keeping this session for around 1 hour, and also depends upon if the time permits, I can show to that all the technical demonstrations. If not, we will have this another the separate session where I can going to be discuss with you as a technical demonstration on this particular the stuff. So that's about me actually. For let me go to that. Okay, I hope you people are able to listen clearly to me, and as well as my screen also visible. So now I hope you know that, okay, I don't want to highlighting this particular the features. Okay, right now you know that how this industrial revolution it is happening. Okay, now first industrial revolution and the second and third and fourth. You know that actually for there is a very clear what I can say, no, that bottom line and also the top line of this particular industry 1, 2, 3. So if it comes with actually for industry 4.0, it is nothing but there is no bounds. Okay, right now there is no top limit on this particular that industrial 4.0. So if you can considering that aerospace and many other the programs, they have that different generations of the stuff is there. Their fourth generation, fifth generation, sixth generation. Somehow with the industrial automation side, okay, there is industry 4.0. It is that actually for that now what we have defined, and now it have created that endless, okay, the engineering possibilities within this particular the industry 4.0. Now let me talk about that what is that the endless, what I can say, no, the technologies are integrated in this particular the process. So now if you see that actually for the critical, what I can say that elements within this industry 4.0, they are majorly what we can say that initially when we started with this the smart manufacturing. So in the smart manufacturing, where actually for typically there are many robots are there, and there is actually for that assembly lines, there are many moving components, sliding component. This is what actually for that how it is managing this manufacturing process. Okay, the digitally. But this process is extended beyond actually for many things. Right now, you can see that the recent enhancement here is that digital twin, where the digital twin is nothing but is that your virtual replica of your physical systems, which is there in the cloud, that actually for monitoring your physical systems and can be on the real time, it's diagnosing the issues. This is what actually for that one of these significant thread out of this the industry 4.0. And other elements you can also can see that where that internet of things and cyber security, cloud integrations, additive manufacturing, augmented reality, and also where actually for the big data sciences, these all the different what I can say, the threads which are emanated from this industry 4.0. So, and this is what actually for the different elements. These individual topics are very vast, okay, topics. So now this particular session I will take where actually for that the autonomous the robots, okay, the development, because in this industrial 4.0 smart manufacturing, the critical the challenges were actually for it with these autonomous robots, because earlier that industrial what I can say, the current most of the industries, these robots are actually for moving within there actually for that access. That means it is a very fixed robots. It can be move around here. Now what is happening that autonomous robots where actually for the autonomous AGR, AVR, this is all kind of actually for the technologies which are the moving components. They have the lot of dynamic stabilities. Okay, these are the challenges are which comes with this what I can say, uh, autonomous guided vehicles. So this is where actually for we are going to be addressing through this particular session, which is the more what I can say, the dynamic in the nature. Let's see that what are the capabilities we are going to be offering for that particular stuff. So now this is the sim center, the portfolio, one of the system engineering portfolio, which addresses that the AGV and AMR. That means automated guided vehicles and autonomous, okay, the mobile robots. This is the two technologies how we could able to be supporting through our okay the engineering the softwares. That's what I'm going to be discussing in this. So I have this short agenda here where how this is the what is their market trends and what kind of the engineering challenges we could able to be addressing, that how we could able to be integrating with this PLCs, and how we can be performing this virtual commissioning, and also to performing that the various load cases and to estimating the performance of these the vehicles. That's what the session what I'm going to be continue. So I'm keeping that the live demonstrations on these the various technologies. These are the different what I can say that the what I can say, these autonomous guided vehicles, which are more predominantly actually for uses in this particular industries. Right now, since there is no top line for this particular this industrial 4.0, and what I can say that now autonomous guided vehicles are there, and we also have this the robotics, which is filling in this particular that assembly lines, and even for the drones which can be transmitting actually for these loads from this one location to another locations. This is actually for the majorly for this the defense sector, they use this kind of the revolutions. And also that the four leg robots and six leg robots, this is the mostly actually for the using for this the industrial automation side, okay, and also for that various the applications are endless in this what I can say in the defense sectors. Okay. So, and these are the various the demonstrations I am keeping, because of this all models are available with us as a faculty members. You can take this kind of the models, and you can be increasing. You can put your own thought process. You can be further can be refining and tailoring to that industrial needs. That's what you could able to support for this industry. So now, as we discussing, now you see that the market of this particular this AGVR EMR are endless. Okay, right now for the any industries, okay, which are the digitally following this trends, or actually for using this particular the technologies like that. You can see that industrial plants, aerospace, manufacturing, marine, and food and beverages and healthcare. There, what I can say, there are plenty of the applications where typically these technologies are leveraging. So now what is that actually for the main challenges are here right now when you have this typical autonomous guided vehicles or maybe AMRs are in that your within your factory, how actually for the maneuverability, what I can say, no, that means they have the very complex terrains it has to be moved. That means they it should be have it should be have the more flexibility can be steer, okay, without what I can say that deviating its specified path. Okay, that is the one kind of the things. And also for how much maximum speed it can go actually for that is how long this particular the most of this what I can say no AGVs are it is driven by this most electrical the power drivens. So it will gives us that how long this particular the robo before next charging, how long it will going to be supporting. So and how these missions will going to be talk to the mission to mission and also where actually for with respect to the people, how it is going to be communicating. These are the various challenges are okay are with these industries. So now you can also can check the see that the market the trends, okay, and within US alone actually for it will going to be reach around 30 billion market by 2030. And also by 2030 they are expecting that it will going to be touch more than this 100 billion market. That means it have the huge opportunities, okay, it's lying with these technologies. And also you can see that since there is a lot of opportunity, there are many opportunities in this market where more than the 650 companies are actually for currently or started this particular this what I can say no this particular the specific market. So, and this could be one of the biggest opportunity for these universities. And since there are many companies, market is very well maturing, so that you can train that students, okay, or university labs, you can be moderate in such a way that you can do the key R&D within your what I can say, no, university environment, and the technologies you could able to be transferred to the industries. Okay, this is where actually for you can leveraging this large amount of the opportunities with this the technologies. So now let's talk about what we can addressing through this particular our portfolios. See now the AGVs or AMRs, this is actually for that very highly sensitive the technologies where the competition is very high. So whenever you are designing any component, it should be meeting that the performance without compromising on the performance. Second, actually for the reliability and also the lower cost. Okay, so you have to be sizing this all possible subsystems, okay, in and appropriately to meet this all kind of this engineering challenges. For example, if you are designing the some component which is not actually for the delivering the performance during your test, what I can say physical testing, then it's very challenging for you to again to remodifying, redoing all engineering, and also it will be you are delayed to that market. Okay. And also, if you are not properly sizing this all components, what will happen that if your motor is not very good enough, it is not providing that enough traction, then you are identifying that during this process, you are actually for that what I can say, no, you are trailing in this market. So how to optimizing this all the things? That's what we are sizing and validation portion. Second thing is that virtual commissioning. In the virtual commissioning element, now what will happen is that actually for that industry 4.0, the situations, the major challenge where it comes actually for that the virtual commissioning side. Okay, the commissioning in the sense when you all the robots you are bringing into this factory and the people automation people actually for they will be creating the certain motion and also they will be creating this all kind of the motion of this particular robot to perform the certain actions. So now these people, what they will do, no, they will be controlling through PLCs. Okay, this PLCs doesn't understanding that what is that physical nature of that one of the system. For example, there is a two moving components are moving very fast. Okay, now PLC controller it is giving that to stop command because of the inertia. It won't be stop actually for it will be further colliding each other. Then what they will do that they identifying that a collision, they will be stopping the controller little earlier, so that what will happen is the components will be smoothly will going to be touched. So these kind of lot of retrofittings they are performing under that within this the shop floor. This is where actually for taking that years of the time, okay, for this to make that the right combinations. So this all the things right now we have this virtual softwares which would allow you to be performing in this within the virtual environment, and you can be optimized controlling strategy you can be deploying into that one so that you can significantly minimizing the commissioning time. Okay, that is the one of importance. And also the steerability. Right now, you know that within the industries, there would be a lot of zigzags and very we have the intricated places where you have to be steer your autonomous guided vehicles. So you should know that actually for the what rate and what is the degree of radius it is required to maneuvering your things. These things, what I can say, no, we have to be well trained. This all the robots, even in the virtual environment, these the optimized controlling strategy we can be deploying within the system so that you don't find all kind of okay the training of the robot and to understanding at that the shop floors in the physically. Okay, and also for this now each and every vehicle it takes its own amount of the time. What is that actually for the time it is really required? Okay, and that's what we can say that the charging when we have to make that next charging, how long this particular the battery can be surviving with respect to the different conditions. Those kind of the studies we could able to do that. Okay, and also you can see that the robo which is following that people. Okay, the that means it is interacting with the human. Okay, so these kind of the robots will going to be have more and more in that actually for in the future. And also for actually for the material handling equipments where that precisely controlling this the motion of this the materials and to placing this all kind of the things the challenges which could able to addressing through these the virtual simulations. Okay, let's come to that actually for the discussion what we can do that here. This is our sim center portfolio. Right now, you know that, okay, any component you can considering right now in the industrial 4.0, all are the mechatronic systems, where typically it electrical components, electronics, mechanical, hydraulics, thermal, and also IoT devices, and also various cloud connecting. So this is actually for this big amount of actually what I can say, the domains are getting involved. Any of these smart component, if we can take in this market, okay. To addressing this one, we have the solution. This is the brand. This is the SIM Center. The solution portfolio is called as a SIM Center, which comes with various system engineering softwares, CIE softwares, and physical softwares. And also we have other verticals also available for this automation, PLCs, this kind of the controllers also available with my another, okay, the digital industry division. So these are the typical, the physics-based simulations, what you can be performing under this, the sim center environment, okay? So now in this particular the discussion, I'm going to be talk about that three the softwares. One is the MESIM software and also Automation Connect and also the pre-scan. These three softwares are supporting for these AGV and AMR applications. Okay. So this is the software is called the SimCenter MESIM. What it is actually for here, and it supports that we have the industry standard libraries we created for that automotive, aerospace, heavy industries, industrial mission. There is kind of the different industry specific libraries and also different physics based libraries which covers that wide range of engineering physics, and also will allow you to be integrating with your PLC worlds and to performing that the various virtual commissioning through that software in the loop, model in the loop, hardware in the loop kind of the conditions. So now this all the things actually for that available within that single environment. We have around 6,500 validated components. That means these components have validated either experimental or maybe it have that literature proof. Okay, that's what the components called, say validated components, what we are supplying through the Siemens. So another portfolio where we have actually for the sim center pre-scan, where the typically this particular the software, okay, where you can see, you can be creating that all kind of this virtual environments, okay. So and also you can see, we supporting that this software having this all kind of this the sensor technology like a camera, radar, lidar, and ultrasonic, and also the various what I can say, um the sensor condition, that means GPS, IMU, and CAN bus, this kind of those things. Okay. So this is the what we can do that. This is the software is very tightly integrating with the MATLAB Simulink. The controlling system we developed in the MATLAB Simulink, and finally they are integrating with this is the controller commands it can be generating, which integrating with the SimCenter AmazeSim. Okay, now we are making that co-simulation between that the pre-scan where actually for the environment definitions, controller in the MATLAB Simulink, plant model in that MSC. Okay, this is the three softwares. It is in the virtually we are integrating to analyzing that various the possibilities. So let's take actually for this one of this example here. Okay, now what we have done, this is the one of AGB model where we have there is a typically you can see that the portion actually for right now you have this is the battery what we have which is connected with this your powertronics. The power it is passing to that you are the drivetrain. From the drivetrain that is which is the traction system it is connected with your vehicles. So like that you can see that we have the trajectory where you can be defining that what is the route it has to be maneuvering that particular the definitions what you are making here. Okay, so this particular the route definitions, what we have giving through that as a tabulated format and also maybe some kind of the signaling, or it comes from this the real world. Okay, what we discussed with this the pre-scan. Okay, so now what we are going to do that actually for here, this will be generating that appropriate the torque demand. This torque demand it comes to that the traction system, then your electrical motor which pulls the power from that your battery in such a way that it is the following the trajectory. Now you can see that this is that you have the plotting within this environment and also you have these animations. Now you can see that whenever you are moving your vehicle with respect to that the certain terrain, what is the kind of actually for that how smoothly it is following this one. Now if you can see that whenever it is moving such kind of the sudden the turning, okay, where you can see that that is AGV it is making some kind of oscillations around that particular point. That means we have to be understanding that what is the root cause of this kind of the things. How is it a plant model problem or controller problem? Those things we are going to be okay analyzing in the deeper. Okay, so now what we have done that actually for the same modeling, now we have considering the different scenarios. Right now you can take that. So now your AGV where the typically the velocity I am increasing from the 0.2 meter per second to that 0.47 meter per second. Okay. So now you can see that at the low speeds, it is exactly following that maneuvering without any kind of the lateral deviation. When if you can see that in the normally where high velocities, when the lateral it is having that a lot of the lateral deviations are there. Okay, so this is where we can be estimating that what is the maximum speed given conditions it can go. Right now we have considered here 100 kgs of the weight and also the 0.3 meters from the this is the center of gravity what we have considered and also platform 8 of 46. It is total is 146. Okay. So now with respect to this one, what is the maximum speed? It can be safely can be maneuvering. Okay. This is the what studies we have done that. Okay. Usually, if these kind of the trails are people are doing and that physically, it would be very expensive to correcting this kind of if at all anything is possible. Okay. And also, for examples, right now, I am increasing that the load, for example, 100 kgs to 200 kgs around, I am increasing now. Now you can see that with the same velocity right now, no, I am restricting my velocity to 0.4 meter per second. Now you can see that with respect to that increasing the load, it is getting that deviating around this particular the points are very significantly with respect to the load is getting increasing. Okay. So this gives you that actually for that what is that optimum load we could able to be placed on this particular autonomous guided vehicle in such a way that okay it can move very possibly. For example, you can see that some industries where we have this what I can say, the water bottles or maybe you have that is the cool drinks. This is the kind of the bottles when you are deploying on that one, when it's actually for the shaking, if that is excitation frequency of this particular the robo, it is matching with this the bottle the frequencies, that is a whole system will going to be get collapsing. This is the what typically it is noticing in this, okay, the industry. So those kind of the things we could able to be minimizing. And also, and height elevation right now, no, from that, what is the CG we have to be maintaining? For example, you are increasing the load CG with a little high elevated. Now, what could be that dynamics are getting involved right now? When the CG is close to that, okay, it is what I can say, no, ground. Now you have that more stability, it would be there. Whenever you are going actually for away from that ground, the CG point, you have always have the dynamic instabilities. This all kind of this engineering possibilities we can be simulating within this virtual environment, and we can come to the conclusion. It will give you that service engineer what is that speed you have to be set. It will automatically, this guided vehicle will give you that information. If you set the speed, it will tell you that I can be maximum weight, this is the weight I can be smoothly can be carry over, this is the CG point you have to be maintaining. So that those kind of the guidelines, okay, within this computer itself, you could able to be the get, and based on that one, the people can be place the loads. This is the kind of technology. Now let me see that actually for that AGVs, okay, how we are going to be controlling through that the controller, that means the PLCs. Okay, this is how most of these industries are using this PLC controllers from the Siemens. And let's see that actually for what is that our capabilities. Okay. So now here, what we have done that this is the center is a sim center MSIM, and where actually for you can see that this is the PLC world. Okay, where we have that the PLC sim advanced, there is a controller where you could able to be creating that various kind of the controlling the models like either C code or maybe ladder diagrams, or maybe you have that actually for the different the PLC, the programming languages which supports this particular the software, that is a PLC sim advanced. So, and also the virtual controllers also could be supported from this way other third party vendors. With those things, we can directly be connecting to the OPC protocol. If at all Siemens controller, directly we can be connecting with our the Siemens the plant models. So, and also if you have any virtual controllers from any third party, we have another platform is called as a CIMET, which can be taken here, and through the CIMET we can be integrating. Okay. So now whatever we are realizing here, I can directly deploying into that my Siemens the physical hardwares. Directly I can integrate. That means the model, that means software in the loop, and as well as that hardware in the loop with the same the physical, what I can say, no, the plant model you could able to be performing. Okay. So this is that advantage. Okay, with very few clicks you can be performing that the both the testings. Once you are performing this test on this mission lab setting up, it would be much easier and it would be very minimum time consuming. So let me take actually for this one of this example here, okay, AGV. So what we have done that we have used that the three softwares here. This is a SimCenter MSSIM. We have developed the tool is called Automation Connect, which connects with our the Siemens the PLCs. Okay. So, and also not only for Siemens PLCs, it can also can be connecting with any third party PLCs also. Okay, this is that the connections what we are establishing here. Now let's see that actually for that the short demo on this one. Now I hope you know that the people who is working on this TIA portal, and where you can see that this is that the typical the PLC the coding what you are making here. Okay. So this is the what I can say. No, it's a continuous controller. It's a PID based controller. What we have taken here. So once the controller model is there, we are directly importing into that the PLC SIM advance. Okay, which allow you to be integrating with the SIM Center MSIM. So now this SIM Center MSIM software, we creating that the plant model right now, the wheels, and you can see that the vehicles, and also where we have the controlling strategies, where actually for the route you have to be follow. So this all the things actually for we are defining that. This is the interface which allow you to be connecting with the PLC, what we are discussing with that PLC SIM advance. Now you can see, this is the controller. Okay, this is that connector, what we can call as automation connect, SIM center MSIM, and we have the PLC SIM advance, and also we have this HMI dashboards. Okay, typically, so you can also can be connecting with the multiple portals are here. Right now, I'm only established that only for the two connectors. Just I can open here, I can be bring that DLL of the SIM center MSIM here. Similarly, I can be bring the PLC SIM, the controller also imported here. Okay. Now you can see that now the initially that is the controller loop, it is getting is opened here. Now what I'm going to do that I'm going to be start this particular right now. No, the controller is started, but still the command is not going inside. Okay. So now where we have these particular the breakout boxes and connectors, you could able to be make through that the HMI dashboards. Right now you can make these connections. You can start this toggle here. Now the command will be passing here right now. Okay. Once you can click here right now, this is the line is getting enabled here. Now controller code is getting executing. Now you can see that what is happening that okay during this process. So let me see that actually for here. This is that where you have the targeting, the reference curve, where you want to be go. Okay. Actually, you see, no, how much you are going here. You are deviating that your reference curve. Okay. So now the same thing, you can see, no, you have that a lot of the deviation with respect to that reference curve. Okay. Now the same thing you can also can be realizing through this what I can say, no, in that animations. Okay. Now when you started this particular the conditions right now, let's start actually this one. Okay, now you see that it is not able to be maneuvering this particular the route. Okay, it is deviating its route plan. Then what we are going to do that? Let's see that is it is a controller problem or plant model. Okay, now we are going to the controller here. You have that is a PID controller tunable parameters. Now I'm changing that actually for my proportional gain here. Okay, right now from the 0.1 to I'm changing that it is a 2. Okay, the proportional gain. Okay, now let's start that program. Okay, you can see that how either the what I can say AJB is following that path or not. Okay, so now you can see that okay now how this particular now you can see, no, it is a smoothly, it is a maneuver in this, it's a path. So what it concludes right now, now virtually we are tuning the controller, okay, to make this autonomous guided vehicles are following that, okay, the specified route, okay. So first of all, we will see that extents of the controller. What is the possibility? Sometimes, no, whatever you can tune the controller, it might be not possible to following. Then you have to be make adjustment into the plant model side. Okay. So since you are at the early in the concept design, you have a lot of freedom to modifying that either plant models or controllers to get that right the combinations of this one. Okay. This is that if you are performing these studies at early in the design process, you could significantly minimize that late design programs. Okay. And also the same approach will significantly support you for this virtual commissioning for this industrial automation side. Okay. Now the many people are saying that by using this virtual commissioning approach, they are reducing that 80% of the commissioning time. Okay. This is that lot of testimonials are out. I will going to be share you later this one. So now another case actually for we have AMR. This is autonomous mobile robots where you have that is it should be interacting with the environment and also with the humans. Here you might be required that the closed loop controller. Previous one what you have seen that is a open loop controller. This is the closed loop controller. Let's see that actually for this in the closed loop controllers where the typically how what we can do that. Okay. So initially for these drive systems, this is the sim center MSIM. You can see that the road profiles and tires and traction systems and the motors and 6 degree of freedom of your the vehicle and all the things we are modeling within this the sim center MSIM software. Now we have another environment is called as a pre-scan. Okay, I told you what this pre-scan is does. It is having that is the portals where actually for you can be creating that your route and road plans that industrial that is the path all kind of the paths and actually for pedestrians and also with other infrastructures all the things you could able to be just a drag and drop from this particular the libraries. Okay, once this will be converting into the 3D visualizations, okay, now it is you could able to be realizing that this is actually for that virtually we created this particular that industrial environment within the software. So and now where we what we are going to do that and you can be creating that all kind of the situations where that whatever that environment how the people can be crossing those all kind of that situations and test cases you can be defining here. Now the sensors right now you can see, with the infrastructure, we are keeping that the vehicle here right now. Okay. Now we are keeping that the various sensors right now. Now you see that sensors, it will tell you that what is the sensor radar. That means what is that it could be able to be visualized. Okay. So now you could able to bring that actually for the sensor locations, or either you require that radars or lidars. These are all the kind of the different technologies like that is, the lidar technologies for short range applications where you have cameras, and also we have the lane maker sensors. There are actually for the different sensors are available within this environment to analyzing that which gives that the more accurate the sensing phenomena. Okay. And also finally algorithm integrations, right? What we have done that here, so we are using this MATLAB Simulink. I hope you know that most of the people here, where we are importing that MSA model directly into this particular environment. The pre-scan environment actually for that what you have, okay, you can be integrating that. The MATLAB will be deciding that based on your controllers, the sensors, it will tell you that and what could be the strategy right now. Okay, we have to be adapting. Right now it is having a four controllers. One is accelerations and braking and also the gear changing or whatever actually. But this is the four situations it has to be taking with respect to that, the situations. Okay. This is where actually for that models it works. Okay. Where we have the sensing from this pre-scan environment, thinking and also controlling strategy, what we are developing in this, what I can say, the MATLAB Simulink environment, SimCenter, MSIM, FMU, which takes this information and it gives you that actually for the position, okay, the position situation where actually it is there, okay. This response, it will go for the feedback to that your initially what you have defined, okay. So this is where the closed loop, okay, the simulations we can be performing for this AMR to considering that the real life situations. So this is one of the testimonial actually for here, that is Tinsville, where these people are expecting that you can see, that is 100 billions of the market predictions by 2030. And also these people, they use the SimCenter, AmazeSim, the software to actually for the modeling and all kind of what I can say, developing this particular robot, which is actually for the interacting with this a human, which follows him and it follows his guidelines. Okay. So this is the kind of the robots actually for significantly will going to be take a the lead role in this the future. That's what actually for what these people are mentioning, that by using the SimCenter, AmazeSim, they could able to be performing that all kind of okay the simulations much early in the design process. Okay. So that's what actually for it helped them to bring the product much faster into this market. This is that use cases are available. We'll share it with you. You can wait further. And apart from that, actually for SimCenter, AmazeSim, now in Industry 4.0, there is actually for this the machine learning, artificial intelligence. This all the things are actually for become a very critical elements into the system. The SimCenter MSIM supports that advanced networking technologies, which will allow you to be take that real life situations and converting as a mathematical models that we are deploying into the cloud, which is actually for that on the real time monitoring that your field informations, and it will be tell you that how much you are deviating from the actual situations. These kind of the advanced neural networkings which could able to mimicking that real life behavior as close to as close as possible. Okay, these are the kind of the technologies what we are having. Okay. So now let me walk through you this actually for that one of this the technical the demonstration. Let me show you that. Okay, still I have the 15 minutes of the time. So now here one of this use case right now, for example, you can see autonomous guided vehicle here, automated guided vehicles, where we have that is a loading profile and it's going for the discharging. It's coming actually for to that the respective positions. So this is a kind of this the route what we have defined here. Okay. And now for the route, okay, you are defining that what is the speed it can go when you have the load, when you have the ideal conditions, what is the speed you have to be follow, outside the accelerations you have to be follow. Considering this all the five the situations, now we are running actually for that the different load cases. For example, if I can run with the different velocities right now from the 0.5 to 1.3 meter per second, now you could able to see that the range it is a significantly reducing right now. Nearly when you are going with the higher velocities, the range it is coming down nearly more than 40%. That means what is that optimum speed I had to be run? Okay, so that my the consumption of the energy would be that very minimal. Okay, and also you can see that another situations where we have considering that what I can say no here. One is that actually for the multiple speed conditions, and another case actually for where you also can see that we are getting the load is getting increasing right now. Okay, when your load is getting increasing, now you can see that what will happen is that the overall this is the very straightforward case. When the load is increasing, definitely the range will come down very less, and also you see that the duration it is a coming. It's normally for the 50 kgs it is coming 8.6 hours. Now it is coming 6.9 hours. That means it will give you that very precisely what is the time required to for this one. Okay, the cases. Okay. Now let me quickly to walk through you this particular the demonstrations. Okay, and if for the detailed discussions, if required, we will have this another enablement session where we are going to be discussing in the details about this all the things. Okay. So this is the Sim Center Amazing software where let me move that. Okay. So now here you can see, this is where we have that is a good number of the technical the demos are available here. Right now you can see that we have that is a various kind of the robo elements are available here. You can see the drone elements, and you can see that a different AGVs, different what I can say no that the different robot technologies. This all the different models are available within this one. Okay, you can also see that all the this is a one library. I just walk through that. If you have the multiple libraries, they have that is various capabilities are there under the solution sections. Okay, now you can also can see that typically for this industrial robots. Okay, where you can see that typically heat exchangers, robotics, and controlling strategies. So this all kind of actually for the complex. Okay, the AGVs and many the models are available here. Okay. Now you can see, there is a recently launched for the Mars robo. Also, we have model here. Okay, it is available. So what I want to say that the software is doesn't have any limitations of modeling this kind of the AGVs. You can be leveraging okay this software. Okay. Now let's actually for that to show you that what is that actually for the same demonstration whatever I'm showing here. So this is your the batteries right now. If you can go to this particular the battery here, we have all kind of the battery technologies right now. The chemistries are it is the part of this particular the software right now. Okay, you can be choose whatever the chemistry you want right now. It is launching here the tool. You can see all the list of lithium ion chemistries are available from the database. Okay, so this is the level of the details what we are going here right now. This is the traction system where we are taking the power here. This is the permanent magnetic synchronous emissions here. Directly you can be importing actually. This is the typical characteristics we have to be defining. These things we are discussing in the later. So this is you have that is autonomous guided vehicle here, where that typically you can see that what are the parameters it comes actually for here. Okay, now you can see that this is that all your inertial matrix of your the vehicle what you are going to be defining here. So now this is the wheels are there. There is a two wheels are the front tractions. Now you can see that the one is a back is ideal gear. Now you can also can see that route planner, you can be defining that the coordinate system and what kind of the route and how this route planning actually for you can be defining that. So this is what actually for the typically this particular the software. Now I'm running this particular the model right now. You can see that the models are typically runs a very faster. Now I'm keeping actually for the multiple scenarios. Okay. Now you can also can see that here within this particular the software itself, you can see that within the animations, how this is, it is exactly following this, okay, the maneuvering. So now what strategy we have to be follow in such a way that you could able to be right now with another case, you can see that, okay, with the different loading conditions. So now you can see that it is able to be still, it is having a slightly oscillations. Now, if you can see that the first case where with the low speeds, so now you can see, it is smoothly, it is getting the following, it is the trajectories. So it will give you that idea about that actually for that, what is that appropriate speeds we could able to be make through that one. And it gives you that all engineering calculations, right? Now, if you can go here, this particular, the motor, you will have this, all these engineering calculations right now. You can see, okay, now Here you can see that what is actually for the speed it is rotating here, and you can see that what is the torque it is getting a delivering, and you can also check that you can see that other parameters, how much of the heat is getting generating here, stator heat, rotor heat. So what are the losses? All kind of this informations you could able to be address it here. Okay. So this is that the full engineering simulations you can be performing that. Another case you can see that this is that the robo, which is that four-leg robo, where I'll going to be show you that this particular the robo, where it is the making the motion. Now you can see that this is the making the motion control. Okay, the robos. It is moving the specified speed and also the moment. You can see that during the sim here within this one, what it does actually for the typically this particular the robo, where we have that is a hydraulic actuator which is moving their arms. Okay, so that's where the controlling strategy which comes here. That means what is the rate it should be controlling the leg, we are giving that the controller to the proportional valves. So now you can see that how the process actually for the during. Now you can see the pistons, how it is this all the legs, the pistons are moving here, okay, appropriately. So this is what actually happening. Now you could also can see that here all the kind of the phenomena, right? What is that? The force, what is the accelerations, velocity, about the CG point, you can see how much of the forces are coming here, all the directions. So now you can see that where you have the center of gravity. So this all these informations you could able to be trace it. If you can go to the hydraulic system, how much of the peak pressures are generating here, how much of the flow rates are coming here, and how much of the force it is getting extended here. This all kind of these engineering calculations you could able to be analyzing that. Another model actually for where we have there is what I can say that this is that another ant probe where actually for where you have that is the six legs are there, which is controlled by each and every arm is controlled by the two motors. Right now you can see one motor here, one motor here, another motor. That means each and every leg it's controlled by that three the synchronous the motors. Okay. So now you can see that how this particular the motion. This is a very complex motion, but platform is a very stable platform. Okay, they can use for extensively for this military, this kind of applications. Okay, now these are the typical model representation for that one. Okay, and we have the some kind of the industrial robots. What is this industrial robots are typically? Okay, now you can see that. So how this is during this operation, how this is the bottles are getting actually for filling here, the to precisely to fill this particular one as per this target. Right now you see that target also getting a moving here, and with respect to that moving target, it is precisely actually for that the filling that okay these things. So these kind of the models, okay, any kind of the kinematics or any kind of the robotics and either mobile or what I can say, no, the fixed robots we could able to be simulating within this particular the software. Okay, so this is where actually for in the details we will have in the discussions. Okay, so and the major objective of this particular the software is that to minimizing actually for that the test campaign. That means whatever you are performing on the physical testing, significantly you can upload this work for this virtual the testing site. Okay, so that you can be analyzing that hundreds of the design conditions at in the early in the design process, and right designs we are passing to that detailed engineering phase, so that detailed engineering analysis where significantly time consuming can be minimizing, and also the physical prototypes will be significantly will be reducing. Right now current industry 4.0 technologies, most of the physical prototype, no company, better technology adapted companies, not more than that two physical prototypes are acceptable. If you are not having that enough engineering skills, then only you might be required that multiple physical prototype iterations. This is that the global trend is going that, which is very much possible through that MBSC protocol within this the digital industry 4.0. Okay, this is about my sessions. If you have any questions, we could discuss quickly. Okay.
Thank you, sir. Dear participants, do you have any question? Please raise your hand so that I can allow you to speak with the expert. please raise your hand.
So I want to see that. How can I expand this one?
Dear participants, do you have any question? Please ask. Please raise your hand. I will allow you to ask.
So, and you possible you can also can send a drop a mail to us. Okay, if at all anything specifically you want to be looking forward, and we will have in the detailed discussions. Okay.
Ashutosh Kumar, do you want to speak? If you have a question, yes. Sir, Ashutosh is there. He want to ask you.
Yeah, please, please.
Ashutosh, please unmute yourself and ask.
Yeah, Astos. I think so. We can't hear you. Okay, could you please?
You can ask also, no issue. I have allowed you to ask actually. Unmute yourself. I think you have a problem with your mic. Sir, the question is in chat box. Can you see this?
Yeah. Yes, 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 yes. The question is about that virtual prototype. Okay. Do you think that without physical prototype, is it possible always to test the mission and product? Yes. See, this is actually for the major objective of this actually for the virtual the prototyping. Okay, right now that what we can call. See, right now, current industrial process where you might be required that the physical the systems to validating its performance. Okay, for and also optimizing the controlling strategies. So now what we are doing that this whole the physical system we are modeling in this kind of the validated softwares, multi-physics softwares, and we can integrating with the controller right now, whatever the controller you have developed, and you can be performing that all the laboratory conditions. You can be creating in the virtually, you can be simulating that. This is that the major motivation behind this virtual commissioning. Okay, this really don't require that physical systems. We might be required that the physical system, that is information. For example, what could be the motor would be there, what could be that traction system, what is a transmission, what is the vehicle dimensions. At least this kind of the basic physical informations we need to modeling into that virtual environment to validating that the virtual prototyping. So if you require the further in the details, we can show you. What I'm requesting you, kindly go to that sim center sim, go to the YouTube channel, type a sim plus any topic. Okay, you will have that a lot of videos we are demonstrations we are keeping in that YouTube channel. Okay, you can get that good information about that one. And after going through that one, kindly let me know if you need the further clarification. We will have the detailed discussion, okay, on the live demonstration.
Okay, so sir, I think participant have now no any question. So thank you so much for your presence and your deep thought about the presentation. And really, we are very thankful for your for sharing your knowledge. We will see in near future with the another topic related to your background only. So, sir, thank you once again on behalf of OP Jindal University for joining us.
Thank you, Sarosh. Okay, thank you, guys. Okay, we'll catch up soon. Thank you.
Thank you, sir. Thank you. Aniket, sir, are you there?
Yeah, Saruji.
Yes. Do you want to say something?
Am I audible?
Yes.
Actually, sorry to say that means I am at a common place, so I am unable to.
No. Actually,
my,
about the presentation, if you
yeah.
have any suggestion.
No. So that's a good that's why I had invited Surendra. So he's expert on like this particular platform on the automation side. Okay,
Yes.
like plant and process, and also because of we are hearing these days a jargon, the digital twin, correct? That is very famous in the industry. correct.
Okay.
That particular platform is supporting that to come with that concept, correct. Because of digitization, sometimes it is very necessary because of the question what Amit or Asutosh had asked, correct. Without
Yes.
just a prototype, so how can we test or like qualify the product, correct. Is it okay, means when we go for the virtual prototype qualification, and what is the percentage of the correction, like means the means actual test.
Correct. Correct.
That's why we are coming up with this concept digital twin. So that means we can create every physical product in the form of digital form, so that over the this digital platform we can test any kind of prototype, and the accuracy we can measure there. We no need to go for the actual physical form generation every time, correct. So that's the
Yes.
concept of this means a digital twin we are creating.
Yes. Yes.
So this digital industry 4.0, that is also one important factor what we are
Yes.
creating, and Surendra has already explained. So
Yes.
only if anyone wants or like interested on this platform, like they can means we can share some of the use cases, or also if they want to understand more something, so we can also arrange a second session where we can go for some problem statement or like some of the specific use cases we can deliver in that presentation if
Sure, sir. Sure. Sure.
required. Yeah.
Thank you. Thank you very much, sir,
Yeah.
for your support also.
No, it's a like good to like it should like every quarter we should repeat this kind of FDP, so that
Okay.
we can also aware about the industry, what is going on and what is the new development in the industry side,
Actually,
correct. So that is really supportive.
yes, sir. So
Yeah.
thank you very much, sir, Suren sir, and you also. So
Yeah.
now we are closing the webinar. Thank you
Yeah.
all the participants. Thank you, sir.
Yeah. Thank you all.